Okay, so today we're going to be talking about just some interesting uses of the network, and we have a special guest here, Ross Wightman. I'll be introducing him in a little bit, and then next time I want to show you how to set up an internet broadcasting station. I got it to work. It's a little tricky because that will enable you then to set it up so that people can hear what you're doing. If you don't want to use an existing service, some of which we'll talk about today, this is a way that you can kind of grow your own a little bit. Okay, and then the week after that is when we're going to have Miller Puckett and Damon Holtzborn come and talk about Quack Trip and give us the ins and outs of that. Then it's Thanksgiving, and then we have a week where we can just kind of catch up a little bit on some stuff, and then the term's over. So yeah, time flies when you're having fun. Okie doke. Yeah, I'm going to start before I kind of turn it over to Ross for a little bit, and just kind of go through some basic ideas about the use of kind of the network to do stuff. So I'm going to share my screen here. Do I need to share my sound at this point? No, I don't. I'm just going to share my screen. Okay. So again, if anybody's got questions, I can't see the chat or anything. So just shout them out really loud. Okay, let me see this. It gets out of here. Okay. This gets out of here. So basically, I mean, we all kind of already know about certain ways of using the internet. I mean, you can go to Facebook and you can stream. I don't know if I need to go through any of this nonsense. Okay, Facebook. Okay, you go here. You turn on whatever. Boy, it's pretty slow. Right. I find, where is it that I find myself here? I thought there was a more. There we go. Yeah, go here. Okay. Blah, blah, blah. Then you can go down and you can up here somewhere. Shoot. There's a place where you can go live. Where is it?
It's like right below that status bar.
Right below the status bar. That's what I thought.
That
Obviously, I've never done this. I'm completely missing it.
It says live video.
It does, right. Oh, right
Video.
there. What'd you know? Yeah, what's on your mind? Yeah, this is ridiculous. I mean, you can figure this out. And basically, this is, it's a valid use of the internet, but I don't think it's a really compelling use or anything. There's other ways that you can stream. You can use YouTube, which is, I do know how to do. Basically, you go to youtube.com, and then you can go here. Boy, I hope this is not affecting my streaming out. Hang on, I need to see something here. No, it looks like I'm doing okay. Weird. Okay, but basically you just go up here and you just say go live, and you can go live. And I think both YouTube and Facebook is pretty good about picking up your device settings so that you can actually stream, in stereo, and the quality isn't bad. You can actually go from other alternative devices and things like that. There's also some what they call streaming software. And we're going to be talking about this a little bit next week too, because we use this in order to get to our streaming server. One that's called Restream.io, which is, I haven't investigated these at all. I'll put these in as links, but basically this is a way that you can kind of set up like a product, not a product. You can set up a studio which allows you to kind of create different broadcast scenarios, and you can reach your audience everywhere. Look at that. I think Restream may be a product that you have to buy. There's another one called the OBS project.com, which yeah, this is kind of more what I was looking for. You can kind of mix different sources, and you can set that up, and then you can stream to places like Twitch. I forgot to mention that Twitch.tv seems to be becoming more and more popular as a place for people to host kind of live and on times and online streaming, but again, that's just kind of a one-way communication. You're producing something, it goes out to the world, and it's kind of like one step above what you would call an async version of that, where you just put something on SoundCloud, and then people can hear your music. Now, I'm not saying that that's not a bad way to use the internet, but I think there's also alternative ways, and that's why I invited Ross Wightman to come and talk. So, like I said, I'll put some links to some of these. There's one other one we're going to look at next time that comes with, I'm using this Rocket Streaming Audio Server, and they have their own kind of production software that's pretty integrated with their product. Again, it's free, which is nice, and that's what I'll be showing in class next time, is how you actually use this thing to create something that you can then interactively work with and get sound out there, and a lot of people can connect to it. But let's leave that for now, and I'm going to stop sharing my screen and turn it over to Ross Wightman. And Ross is currently at Yale, and he's in, I can't remember what you're director of, but you're director of several interesting initiatives there. Yeah, so I'll let you tell us. It's on the web page though, so you can go there and click on his profile and learn all the great things that he's been up to. But I was talking to him over the summer, and I discovered he knows an awful lot about networking. And I even verified that with Seth Cluett, Ross. He goes, "Oh yeah, that guy's like a genius." So anyhow, let me turn it over to you. He's going to take about 15-20 minutes to talk about some of the work he's doing. And yeah, give us some ideas, I hope. All right, Ross, it's all yours.
Well, thank you. That was a very kind introduction. So yeah, I'm gonna talk about two pieces that are gonna be pre-recorded videos of this stuff in action with other people, and then kind of demo some of the stuff myself, so that you can kind of see it in action, and we'll go back and forth, talk about setups and different things. So I'll just say off the jump, there'll be a lot of changing of virtual microphones and video and stuff. So bear with me with that stuff. It gets, so sometimes if I'm talking and I'm not being heard, just holler, and hopefully I'll be able to fix it quickly. Yeah. So yeah, so as Brad mentioned, I'm currently working on a few projects at Yale. I was there for the last 2 years, and I graduated virtually back in the spring. And so kind of around that time, or for the last couple of years, I've been a teaching fellow for laptop ensemble courses. And so when when everything kind of went sideways with COVID, we had to kind of reassess the laptop ensemble and figure out ways to potentially kind of play remotely. And you'd think a laptop ensemble would be pretty well fit to do something like that, as opposed to acoustic instruments. But there was like a lot of hurdles. So hopefully some of this stuff that we've done will be helpful to you and other people. I have some articles and stuff coming out about this stuff in the near future. So hopefully it'll get spread far and wide so people can start doing stuff with this. So one of the things me and the professor of that class is Conrad Kazmarek, who I'll be just like talking about a good amount in this talk. We were trying to figure out these things, and a lot of our work deals with for laptop ensemble uses audio visual. So kind of being able to do interdisciplinary work in Zoom was something that we wanted to do from early on. So figuring out how to kind of hijack the camera and do things was pretty important early on. So I'll kind of demonstrate that right now. So if you can see me, hopefully spinning around or moving around. So what's going on here is I'm using MaxMSP with OpenGL to and some other things that I'll get into to kind of chain this in, but essentially using Max, which is my kind of preferred software to use. You're able to use OpenGL, which is a virtual graphics rendering program, which is nice. Different than Jitter. If you're familiar with MaxMSP Jitter, GL is a little nicer because it's on the GPU as opposed to the CPU, so it frees some stuff up, and there's kind of interesting things built in. So one thing I always like to show whenever I demo this stuff is turning into different objects, which is really fun. So here's me as a cylinder, and you can kind of get inside, spin around, which is always kind of nauseating and fun, and do different things with the color values and create different sort of textures and things. And there's kind of stock objects like circles and cones and all sorts of cool things that are. So that was kind of the initial, like, okay, cool, we can get our stuff from Max visually into Zoom, and simultaneously obviously working on getting our audio in. And also, just as a reminder, because it might not be super obvious, but like obviously you can get the Max stuff in, but you have to screen share into Zoom, right? So the way we're doing this is setting up essentially a signal chain with these two outside applications, one being called Siphon, which I could just drop these in the chat. Siphon and accidentally. Let's see. Siphon and Cam Twist.
Yeah, I'll put links to those on the class webpage.
Okay, right on. Yeah, and so there's essentially a set of externals for Max MSP where you can communicate with Siphon, and from there it essentially captures that audio, and then you pass it to this thing called Cam Twist, which is like a video selector, which comes up when you have it installed in your video. Like if you go to your bottom of your Zoom window where it says stop video and that little caret next to it, you could select Cam Twist from there and then have Cam Twist look at Siphon and have Siphon look at Max MSP. So it's a little convoluted, but it works pretty well, and that's kind of been the setup I've been using since about April. So then we kind of figured, as one does working in a new medium, like kind of repurposing older work to kind of work for this format. So now this has gone through quite a few stages, but I'll kind of show you the most recent version. So this is a piece that's by Conrad Kashmarek, who teaches that class. And so we worked on developing it to be able to play. So each person can individually play. Oops, sorry, it's playing and I can hear it, but you can't. I'll turn it on in a sec. So it's well, I'll just kind of show it to you while we talk through it. Just give me one sec to change all my settings really quick. Okay, so just proof of concept, and I'm the screen share, but now you can see I'm this spiderweb looking thing. So now let's see if I can screen share again. Yeah, cool. So we've been developing this recently. We've been kind of getting into making Max for Live objects. So if you're unfamiliar with Max and Ableton, so Ableton purchased Cycling 74, which develops Max MSP, and so you can essentially create Max devices inside of Ableton, which has been really cool for us for reasons I'll get to in a second when we tried to figure out audio routing stuff. So with this, it's cool because you could like make an instrument, map it. I have an Akai MPD 32 over here, which is just like a 16 pad sampler, which I've mapped to this instrument for this piece. And so you have, let's see, where did that guy go? You got this external window, so this is your coming out of Max / live at this point. And so if I gotta change my audio stuff really quick.
Okay, we're not hearing you, Ross, but we're hearing a clicking. Okay.
Okay, if this if you don't hear my speaking voice, that'll be okay. If you can hear the other stuff, hopefully. So
We
let me
can, okay,
just.
we can hear your speaking voice now, but the other stuff stopped.
Okay, so you could hear like a sound
Yeah, I was going.
before. Oh, cool,
Okay.
cool, cool. Nice. Actually, you know what? I could just do it the old-fashioned way and just screen share and include computer sound. That should
That
hopefully
should
work.
work.
Maybe I have to go into audio output here and go into Zoom. Yeah, so many things.
Have you noticed
So yeah,
the
yeah,
fun sampling rate shift that it'll do when you go directly into Zoom?
yeah, it gets
Yeah.
pretty goofy.
Yeah.
um, but yeah, I'm curious. Can you hear that sound? Okay, cool. So what's going on here is, so as I demonstrated a second ago, like I can get this visual into my Zoom window, and then I can get this audio generating from this Ableton session, right? So the reason we're kind of really interested in Ableton is because we've been using this VST called Audio Movers, which maybe you might have heard of. So it's pretty awesome. It's a relatively high fidelity, low latency VST that you can stream audio. So the way we have a lot of our stuff set up these days is like we'll drop one of these, a receiver onto a track, and then, or actually, so usually on a return track. So like over here, got the return track, you put in your credentials, you log in, it generates a link. And then what we do is in Zoom, we'll drop the link to each other in the chat. There'll be a host computer, which will take all our signals, mix them down. And then what we do is we mute our own individual track, and then it's kind of like a monitor mix situation where we connect here to that mix down track, and then we're able to listen back. So we kind of play with latency, but not, you know what I mean? It feels like we're all kind of latent at the same exact level. And the audio quality is like really good, much better than like Zoom. So Audio Movers, just FYI, is not free, unfortunately, but I think it's worth the money in these days when things are happening where it's hard to play. But there are also really good alternatives, like Clean Feed is one. I'm sure you know another couple. Like you're going to talk about Jack Trip soon. So
Quick question for you from
yeah.
Nicola. He says, is it only
Oh, cool.
stereo or does it do multiple channels too?
Yeah, good question. We have done some stuff where, so you could take like there's these surround, like in Ableton specifically, you can drop these AMXD surround panners on, and we've done a little bit of work with ambisonics. There's someone at Yale who just graduated this year, undergrad, and she's been working with she created this app called Gyro. I can send that stuff along. It's relatively new, but it's kind of a stereo headphone ambisonic kind of configuration. So we've messed with it a little bit to certain degrees of, you know, what's the word? Liking it. But usually what happens is the person who's the mixing computer, the host computer, will put those kind of effects on, or like add a little reverb or something, maybe some kind of some panning. Does that answer the question, Nicola?
Well, my question was because I encountered audio movers before once. And that was seeing a performance by Chris Salter,
Cool.
performing in Berlin together with people from Tokyo and from Montreal. And he told me that it was doing only stereo, and I was curious if that was really the case.
Oh.
You know, if audio really limits the audio stream to stereo.
You know, I'm not sure, because we've mostly just been sending out stereo and then receiving back other things. But honestly, that was a while ago that we were trying that stuff, and I can't remember if it like actually worked or if we, you know what I mean?
Yeah.
But yeah, I'm not actually totally sure about that, but I feel like that's something that they would be developing if they know what's good for them. No, I don't know. We'll see. But cool. So yeah, so this so again, the way this piece works, and then I'll kind of play a little clip, is if you, the mouse controls left, right is octave. So you'll kind of see in here the octave changing, -3 all the way down to -5. 0 is dead center, +5, so 10 octave range. And then you have this detune function up and down. So, and then you can have it mapped on my controller. If you look down in this area, you'll see like I can change the speed, the resting pulse of this guy. I'll just break it really quick. And then this you can change the pitch. So for instance, if you put it on 1, it has a rate of once. You know, and if you're in the center, right, go over, pop up the octave. This you change the pitch. And then so like if you had it on something like 10 or so, right? And then the cool thing is you can map other things to it. So like I've got the dry wet on a reverb mapped here. And you can also change like the attack and release. So you can get really nice textures with a pretty, but I guess the main reason Conrad was interested in making this was, you know, different people can sit on different resting pulses, so you can get really kind of complex, dense, polyrhythmic textures. So I will play a little teaser clip of this, and then I can send the video along if you want to watch the whole thing in the future. So this is a little sextet recording we did last Wednesday with the band. So you can see the host computer is screen sharing. So this is all recorded in Zoom with audio movers. Hopefully you can hear that. And so there's different sample packs as well. So some people are playing toy piano samples. Some people are playing, there's harp samples, piano samples. I think there's an 808 pack, but I don't know if anyone's using that. That sounds kind of funny. And then the cool thing with Ableton is like you could just slap on any effects that you would want, so you can kind of get a pretty broad amount of sounds. Just kind of pop a little later. So, yeah. Anyway, I'll send that video along so you can kind of check it out. I just want to get through some more stuff.
Yeah, anything you want to send me with links, I'll put them on the webpage. That would be kind of cool. All right.
Cool. And then so now I'm going to talk about a piece that I adapted by actually a Columbia alum. I think he's a student of yours, Brad, Jeff Snyder.
Oh yeah.
So yeah, this is a piece that I really love by Jeff. And if you actually look up the recording of it that Jeff has on his website, Seth Cluid he was on the gig.
Yeah, Jeff's teaching down at Princeton now. He's in charge. He actually has kind of Ross's position at Princeton. So,
but yeah, I don't really have a real position, but but yeah, yeah. So cool. I'm gonna kind of do it reverse this time. So I'm gonna play the recording. So this is a quartet this time. Oops, I might have screen shared that wrong. Sorry. Cool. So I'm just going to kind of pop to like here, and then I'll just skip through it, and then I'll show you the patch. Can you hear that? Yeah, cool. One of my favorite parts, but I'm going to skip ahead for the sake of time. one part I really like on the find. Yeah. Yeah. So yeah, that piece like really blew my mind when Jeff first showed it to me, and so I wanted to. It was just kind of fresh in my mind, kind of right at the beginning of COVID, and when we were trying to figure out this remote laptop ensemble situation, and I was like, wait, I know a piece that deals directly with using the webcam, and so I was like, this would be like a really cool piece to adapt. And so as we're kind of figuring out, the whole cam twist situation set up with Siphon and figuring out audio movers and all these kind of like parts, the final step was figuring out port forwarding, which is used in that piece. So it was kind of like the perfect storm of all the things that we were working on, as well as a piece that I really just wanted to be able to play regardless of the situation. So I'm happy to have that recording, and now I'll show you the kind of patch and how it functions. This one's broken a few times on me today while I was testing it, so no promises. If you know Max, you know what it is. So yeah, in here, so when Jeff gave me this patch, it was like a really different. It was set up really differently, right? So it's a piece for four laptop players, laptopists, if you will, playing with a host computer on the fifth computer, which is kind of a typical laptop ensemble setup. And so those four kind of client computers are sending out to the host computer not only audio. Actually, I'm trying to remember if those generate their own audio or if it. I'm pretty sure they generate their own audio, and then they're also pumping out the matrices. So in Jitter, this is considered a matrix, and you have to do these, jit.net send, jit.receive, which are like really, really cumbersome because it's like a lot of information moving at once. And so I was like, wait a minute, I know a thing that, I'll get to that joke in a second. So the thing was, Jeff was saying to me, he was like, one of the hardest things, actually, I'll kind of get on the screen share for a sec. He's saying one of the hardest things was, after each person put out their matrix, then the host computer had to arrange them on a grid that would then go to a projector in the hall, and then the audience would see it. So I was thinking to myself, wait a minute, I know something that arranges video tiles on a screen, right? And so I was thinking with Zoom, if we could figure out that stuff with the GL, which we did, and figure out how to send our audio individually, then we would be able to do this. So there's kind of things that got changed. Actually, a whole bunch of things got changed in this patch. And primarily, the thing I'd like to talk a bit about now is, where is that guy? Oops, wait a minute. There's this EST object, which has become, oh, okay. I'm actually in a different version of this patch so that I could kind of demo it in Zoom, and then I can kind of show you. I'll explain why it's different in a sec, but if I kind of change my audio status stuff again in Max. Oh, don't you hate it when the Zoom stuff gets stuck in the way of the thing you're trying to click on? Sorry. Zooming in the old-fashioned way with my face here. Give me one sec. Cool. So now what I got to do is change my mic in our friend Zoom. And hopefully you can still hear me speaking. Yeah, cool. So what I'm gonna do is pump this up and then probably break it, but that's okay because you already seen what it sounds like. So can you hear that sound? Okay, cool. So I have this hooked up to Logitech HD, the kind of classic computer music flight simulator joystick, everyone's favorite. So with this piece, you can kind of change the dimensions of the matrix, and there's a scan line that's reading it like a wavetable. And so there's these kind of different settings you can do, and kind of like invert it, which is like my favorite static sound. And so it's a really awesome, yeah, I broke it, cool. You can still hear it, but it's broken. So I'll just hop out of there. Feedback. Together. Okay, cool. So yeah, I'm not doing right now, but that's sort of just a demo patch that'll work through Zoom. So I'm gonna act like I don't care, and I'll show you the how we do it for real with audio movers. So initially, I had kind of thought about making a Max for Live object as well, but since that piece really deals with matrices, you kind of need to use jitter as opposed to OpenGL, because OpenGL will kind of like round things. And so instead of kind of investigating the right way to do that, we just kind of kept it all in Max. So now if I show you, so there's this conductor patch here. So this is where the port forwarding stuff comes in. So yeah, maybe actually a little sketchy to share that just because it has people's IPs. So maybe, yeah, be careful with that. But that's the thing that's sketchy about port forwarding, right? You got to send someone your IP and you've got to send them an open port. So in Max, the way we kind of set this stuff up, right? Because in that piece in Ghostline, when Jeff originally wrote it, the host computer is sending out all these individualized floats, which are interpreted as pitch values that are in these kind of just intoned, you know, kind of essentially these chords that step through. There's like 60 cues that step through throughout the piece. So I had to figure out a way to have a host patch essentially sending out those as we kind of progress through the piece. So if you watch that full video later on, you'll hear like all the kind of fundamental frequencies that we're scrubbing through with the webcam are getting changed by that host computer. And so what we did is there's a drop down that says, who are you? And we have everyone from the group just like listed in there. And when you click that, it'll say, okay, it'll go to like a call, a COLL object, which will have in it, you know, everyone's IP, everyone's port that's open. And then so it'll connect you. You just say like, I'm Ross sending to Brad, you know, I am Josh sending to Ross. And then you can kind of set that up. And so we've kind of stripped that and moved that into other patches as well.
Yeah, we're going to be going through this IP address and port forwarding stuff later in the class today too. Okay.
Cool. Yeah, it can be really cool if it works. As Brad and I were talking about earlier, sometimes it doesn't want to work, but it's with that piece, it was cool because essentially where that DAC, the at the bottom where the sound comes out of, that was, instead of just going to like your headphones or to any of these other things, it was going to a VST object, which was opening up audio movers. And then so what you would do is you would just send that stream to audio movers. The host computer would collect that stream, put it into an Ableton track, mix that, and then the thing you would actually hear that went to your DAC was an audio mover's receiver. So then you would hear the mix down. And so you're all able to play like in time together. And then what we would do is, you know, each of us would have our GL stuff displayed in, you know, in Zoom as per usual, but we would have all of our audio being handled by Ableton. And so we could monitor it back. But the really cool thing about this stuff is essentially you have like comms between all of your players, right? You can talk to them, you could kind of do guided improvisations with this stuff and like speak to each other. Whereas that won't show up on the high fidelity recording of it. So that's kind of a really fun part of it. You can just sort of be like, okay, now we're all going to like put our fingers in front of the screen and do this. Now we're all going to like do this. We're going to go back to cue, whatever, you know? So that's been kind of a cool backside of this stuff. And then for my final trick, and probably my most daring trick, I'm going to demo this this motion capture stuff that I've been working on through Zoom. I can open it. I just sort of tidied this patch up today.
Question about the audio
Yeah.
patch. We were just talking about, and then I forget the proper name for it. That's creating the streams for you.
Oh, audio movers. Yeah.
Yeah, audio movers. What is the latency like? Audio and was it acceptable? Could you work with it, etc.?
Yeah, it was acceptable. I think it's a good question. So if you're playing like real like groove oriented music, and time is of like the utmost importance, and synchronicity is of the utmost importance, you know, you're still on a computer. There's still going to be latency, so it's not perfect. But like for that piece, the first one I showed, like spinning plates, that all deals with rhythmic relationships. But since everyone is out, mixed down, and sent back, everyone's latency is the same effectively. So that's kind of useful. You sort of have to still, you know, you hit something and then it happens like 10 milliseconds later. But yeah, around the area of 10 milliseconds generally, but the quality is good. So it's been good for me. And generally a lot of the music I'm interested in like is a little more free rhythmically. So it's kind of been okay for me, but I understand that's not the same for, you know, everyone's needs musically.
I'm going to be old here, and I'll confess something. I was commissioned to do, me and Dan Truman and Curtis Bond and Tommy Hahn, a few others, we were commissioned to do the inaugural pieces for the Princeton Laptop Ensemble. This is like back in, 2003. I don't know when it was, but it was a long, long time ago. And my piece, it was an homage to Paul Lansky, and his stuff can be very rhythmically, especially his idle chatter music. And so I wanted to be able to have all the ensemble members sort of coordinated rhythmically, where it was kind of a groove-oriented thing that was kind of important. And I kind of inverted it. And what I did was I had a master computer sending out a pulse.
Right.
And that way everybody received it. And then what it did was it just aligned everything to that pulse so that when everybody would play their stuff, it would just come out in time. So that's one possible way you could do something like that, David.
Totally. Yeah. Just kind of being able to sync MIDI clock. Like once you can do that, that was another thing we sort of experimented with earlier. Because then everything kind of just is quantized and sounds together. So let's see if this guy is working, and then we'll see me dance, and then that will be so I'm curious. You'll know it if you hear it. So hear something? Is that hard right? Yeah?
Yeah, seems so.
Yeah, we're hearing it in stereo, definitely. Yeah.
You know, it's not the all-time greatest sounding thing ever. So essentially what that is those are samples. Those are samples that are recorded in a Costco in my native land of New Jersey. Back at the beginning of COVID, I was kind of interested in recording whenever I went outside, which is rarely. And so essentially, here, I'll show you the patch. So what's going on here is I have these little bee patchers I made. Oops, like that. So essentially what these are doing is they're just reading just different audio files, and they're receiving positions from my face, amongst other things. So you can kind of see the way that that's scaling, right? And then if I go left, right. So that's just kind of, messing with pitch and speed of the samples. Nothing too groundbreaking. And then this is what I just threw this in earlier today. Just like a little low res filter that I have mapped to my hands, so you can kind of get those like that kind of stuff, and that was fun. And it's cool because this is using PoseNet, which you can check out. It's really cool. Just uses webcam input to, you can kind of, a lot of people have used it with like Weckinator, Rebecca Febrink's totally brilliant system of machine learning, where you can kind of train this thing to recognize certain poses. And so it's cool because it outputs like position as well as a confidence meter. So like you see here, if it's like, if the confidence is above 40% that it's there, then so you'll see like, now my wrist is up, it's like, yes it is. But if I kind of do some stuff like this, it's not sure that it's seeing it, so it won't. Whereas if that's down to like, 1 or something, then it's probably more likely to just be on. So that's a really useful thing. And yeah, so this is I'm glad this worked through Zoom. This is a patch that's been known to crash. But yeah, so essentially you just, you're taking these streams of whatever you're mapping, the motion that you're capturing, and then you're able to like route the different, it's essentially like a dictionary, like a JavaScript dictionary that's saying like where your nose is, your eyes, these different things. And then you can say like, route the nose to say like, follow the nose. And then you can put the nose to whatever parameter you want. You can have it like a filter sweep or something. And then you can kind of combine those things, put in different, probably some better audio files, and do things like that. So I guess I'll kind of stop there, and then maybe I'm happy to take questions if people got them.
I was going to mention, it's kind of funny. Great minds must think alike, because that's very similar to some of the stuff that Owner showed us a couple of weeks ago with machine learning. He also used the Weckinator to look at like facial positions and everything like this. And yeah, pretty cool stuff. Yeah. Anybody have any questions for Ross? I mean, if you don't have them now, I'll be happy to pass along his email address, and he's very good about answering email, unlike I am sometimes.
Try.
I have a very practical question, and it's also very specific. I am involved in running a music festival in New York called NICEMP, the New York City Electroacoustic Music Festival. And I'm trying to convince them that maybe next year, because it's unlikely we're going to have public concerts, that we can do something new and different using tools that allow sharing. And the goal is that the artists, the composers would do the heavy lifting, and we would help to coordinate it. But my question, and if you have reservations about this, you don't have to answer. But I was just curious, not interested in any of the software that's being demonstrated here, but just passing on information about some of the tools, Siphon, CamTwist, CleanFeed. I know we're going to have more about JackTrip, to that community. Just my question is that okay?
Yeah, of course. I mean, it's not my stuff, I think that's the beauty of it, is like you find it and then you kind of put it together, So for sure. And yeah, put me in touch with anyone who's trying to figure it out.
Okay, that's where the danger begins.
Yeah, that's true.
If you would be interested to lend expertise, that's a whole different conversation.
Yeah,
But
right, right, right.
that's something that you are curious about or willing to do, even on a limited basis, that would be great. But I wasn't asking that question. But now that you brought it up,
Totally. Yeah, I played there last year. I guess it feels like forever ago. 2019,
okay,
I played the Davidovsky synchronisms.
okay.
Um, I
Um,
think it was the last night of. Yeah,
Yeah,
it's
I forgot to mention he's like a really accomplished bass player too. So
I'm pretty sure I saw that. Yeah. Um,
Josh is writing me a bass piece actually as we speak.
like,
oh,
okay.
this is such a small club, man.
Well, maybe I'll get your email from Brad.
I
Sure.
just put it out in the chat for everybody. Sorry, Ross, but
All good.
Thank you.
okay, gang. Tell you what, why don't we move on to phase 2 of the class, and we'll get as far as we can. And like I said, this class is intended to work also with next week's class. So whatever we don't get done today, we'll continue because today we're going to concentrate on the network control of something or remote control of something. Obviously, that something will produce sound, and then next week we're going to concentrate on how do we get that sound out to the world. So anyhow, and like I said, I'm going to use this as an excuse to kind of show off a few more points about RTC mix and some other things. But I want to explain, first of all, a little bit of just basic background about some of these terms that you've heard. And this may be just ridiculously stupid for most of you. But what the heck, I feel like I should probably start somewhere. Let me share my screen, and I'm going to share my computer audio with you guys this time too. So let's do this. Okay, share. All right, let's get this down here. Hide this away. All right. Okay, so first thing is I just want to cover a few sort of terms, okay, that you've probably heard. I mean, first of all, everybody knows what an IP address is, right? Okay, I'm assuming. All right, can you see that, by the way? Is that too small? Do we make the font bigger? You're going to have to shout it out.
Looks great.
It does. Maybe I'll do this. I'll just zoom this out. Hey, look at that. Whoa, there we go. Yeah, now I can see it too. Okay, okay. Well, an IP address, just IP stands for Internet Protocol, and you've probably all seen those numbers. You know, 128.35.178.2 or something like that. Basically, each one of these little sub numbers is an 8-bit number. So it goes up to 255. You know, 2 to the 8th. And it's a way of kind of disambiguating where packets, I'm going to talk about packets in a second, where they're going on the internet, and routers and these things kind of deconstruct that sort of sequence of 8-bit numbers to say, oh, you should go here, you should go here, you should go here. And they transfer things back and forth using things called sockets, okay? And sockets come in 2 different flavors. I'm going to get to that in a second. But one of the things to be aware of is that this is basically translates, if each one of these fields is 8 bits, that's going to be a 32-bit quantity, okay? And 2 to the 32nd is about 4 billion something. And it turns out that that's woefully small for what the internet supports today in terms of machines. So we have to deal with these things. When Ross was talking about port forwarding, what that means is that a lot of times you're going to have an address for your computer on what's, you know, is a local area network, all right? And these things called routers do what's called network address translation. That was a thing that was invented by Cisco, where basically you can have a whole set of internet numbers on one side of the router, but it only presents one network address to the other side of the router. So basically you can have this huge kind of fan thing, and you can accommodate all the devices so far in the world. They're talking about a new internet protocol that's going to change that, IPv6, but it isn't quite here yet, okay? And these sockets, basically, they are set up, that's an internal programming thing. You create a socket, and that's the thing that listens to stuff coming from your hardware, you know, your Ethernet hardware or your Wi-Fi hardware or something like this. And you address particular sockets with what's called a port, okay? So you're going to be primarily dealing with 2 different things. You're going to be dealing with a host, which is that IP address, and then a port on that host, okay? And there's a number of ports. Ports basically, whoa, look at that. Oh, I just love Word because it just stop automatically. Yeah. Basically, ports again are one of those magic numbers. It's 2 to the, I forgot. It's not an 8-bit quantity, maybe 16-bit quantity, something like that. But basically, they're numbered up to 6555, whatever. I guess that's a, oh, whatever. It's an 8-bit number unsigned. Yeah, whatever it is. Okay, but basically, a lot of these ports number 0 through 1023 are all reserved already. And you've already seen some of these. Sometimes when you see like a colon 80 or a colon something like that, that refers to a port in an internet address, okay? And port number 80 happens to be HTTP. That's where your web stuff comes from. There's other ports for Telnet, I think is 23 or 25 or something like that. All these different protocols that we have for communicating with machines. A lot of the common ones, SendMail, you know, they have specific ports assigned to them, okay? Now, ports above that from 1024 up to 49151 are called registered ports, and they're free for us to use, and we will be using those. So essentially you kind of make up your own port, and if you're unlucky, you happen to hit a port that somebody else may be using for something, there's no good way to really keep track of these things. But chances are you're not going to, okay? Then there's ports 49152 to 65535, and that's an unregistered port, and you can just do all kinds of stuff with them too, okay? Just to kind of get that in your head, all right? Now, the information that comes on these ports is structured in 2 basic ways. One is called TCP. Okay, that stands for Transport Control Protocol. You don't really need to know this. I just feel I have to do it because then I feel like a professor or something. Okay. The other one is called UDP, which is called Universal Datagram Packet. And they all talk to these ports and these sockets and all this stuff. What's the difference? Well, you can set up a port to be one or the other. Actually, ports can also be both, okay? They have to do with how they structure the information that they're carrying, because these are basically just data structures. One part of the structure is in fact that internet address and where it's going to and all the stuff that goes along with that. Another part then is the data that is actually being transported. TCP is probably the more common one used in the real world because that guarantees that your packets are going to arrive. The weird thing about the internet is that it splits your signal that you're sending, your text or your audio or whatever, into a bunch of these little packets. And the packets each find their own way to your computer, and they might actually arrive out of sequence. And the whole mechanism will then sequence them properly and create a coherent message. The reason for that is kind of interesting because the internet was developed by the thing called DARPA, which is the Defense Advanced Research Projects Administration. Probably most of you knew that too. And the internet was specifically designed to withstand a nuclear attack, so that if like half of the United States just fell off the map, these little packets would still find their way back to your computer so that you could effectively launch the counterstrike and, you know, destroy the rest of the world. Fun things. So anyhow, TCP guarantees that your packets are going to get there. Okay, it waits for an acknowledgement signal to come back. As a result, it's marginally slower, not really. UDP is what we generally use for music stuff because that just says, all right, here's your packets, and it just blasts them out. Sometimes you might drop a packet. It doesn't care, but it does kind of maintain then the integrity of the flow, and the timing of the flow is kind of critical for musical purposes too. So we're going to be using UDP for the work that we're going to be doing, okay? Let's see now. All right, so that's enough about the internet for now. Let's go ahead and start working on something that we're going to have make sound that we're then ultimately going to internetize, okay? And I'm going to steal an idea. Talking with John Levy earlier this term, he said he wanted to do something where he could take several parameters and map them onto some sound producing process. You know, the parameters may come from somewhere else, and then use that as a way of sonifying different data streams or different aspects of a particular construct or something like that. So I'm going to do an abstraction of that, and we're going to do something very basic. I'm going to assume that we have two control streams coming into something. And I want to create, first, I want to show you some RTC mix stuff. So I'm going to create two different versions of this. And ultimately, we're just going to turn one into into our internet thing. But is this all going over okay? I mean, is this too basic? Is this too stupid? I can't really tell because I can't see anybody. That's what's so fun about lecturing on Zoom is, I can just like, spew out all kinds of weird stuff. And yeah, anyhow, well, let's go ahead and do it. All right, I'm gonna build this up using the my wonderful RTC mix tilde object, of course, in Max MSP. And the first thing I'm going to do is I'm going to create a very simple granular process. All right. Let me get things going here. Come on, Max, you're starting, please. Yeah. Boy, computers. Here we go. Okay. So let me get this going. All right. And I'll put up my favorite patch, RTC mix tilde. Okay. All right. And I'll put it a bang here. Okay, and I'm going to make this bigger because I can't see it very well because I'm old. All right, so there we go with that. Can you guys all see that okay? Okay, like I said, this is all, you can even download it already because I already put these on the website. Okay, but easy DAC, we'll get our sound coming out. Dun, da, da, da. All right, life is good, okay? So let's create this little granular process, okay? And basically, I want it to be set 44-100. That way, because I can generate some very small grains and I won't get the zippering effect from the control rate problems. Okay, I'm just going to declare a couple of variables here. We're going to say an amp equals 20,000. Amp env, we're going to create one of those nice little line things with 1,000 points, and it's starting at time 0. It'll be 0 at relative time 1. It'll be 1 at time 2. It'll be 0. So they'll just create a nice ramp that goes up and down. Okay, and then I'm going to create a waveform because I want this to be a little bit better sounding than just a sine wave, even though sine waves are cool. But let's just do this for fun. Okay, make table. Okay, and I'm going to say it's a wave. Okay, and I'm going to say it's going to be a square 3, which will be a square wave with 3 harmonics. So it'll be still kind of mellow, it won't be like obnoxiously square or anything like that. Okay, and let's make the duration of each of our grains be 1/10 of a second long. Okay. Now, just for fun, let's set a low frequency of, say, 300 hertz. And let's set a high frequency of, say, 700 hertz, okay? And let's now create our little sample generating loop. We'll say start equals 0. And then we'll say for I equals 0. And let's generate maybe 20 of these. Okay, I is less than 20. Oh, let's do a bunch of them at first. I is less than 100. Okay, I equals I plus 1. Okay, and we're going to say our frequency is going to be equal to I rand, and we just give it low freak and then high freak. Okay, and then we'll generate a wavetable. Can't type. Okay, start at time start, duration of dur. Okay. Amp is amp times amp env, which will give us a nice fade up and fade down. The frequency we've already chosen then. Let's put it out in stereo to both channels, even though I only have a mono channel signal here. Remember, 0 is left, 1 is right. And then we're going to use our waveform as the waveform. That's an optional parameter for wavetable. Okay, and then we say start equals start plus dur divided by 2. So it'll go halfway through the next grain, okay? And that's what we're going to do, all right? So let's hear what it sounds like, okay? Okay, so let me save this just in case. Let's put it in here in week 9. Okay, and I'll call this Gran 1, class Gran 1, okay? All right, so let me now go to my audio status. And let's make our output device the Zoom audio device, okay? And hopefully, you guys will hear this. Ooh, did you hear it? Was it too loud? It seemed pretty loud to me. I'm gonna turn it down. Okay,
I
here we
think
go.
it was good.
Was it good? Okay.
Yeah.
All right, I'll keep it up then. Oh, I know why it was too loud for me. I had my volume turned all the way up in my headphones. Okay. Okay, so it's granulating. Yeah, happy grains. Oh, isn't that fun? Okay. Yay, 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 yay. Okay. Okay. Now, we want that to continue forever and ever. Okay. So I'm going to generate a max bang when this whole loop has unrolled, which means it will be max banging at start seconds after in the future. So it's going to start at 0. It's going to go start equals 0.1, 0.2, 0.3, 0.4, whatever, whatever. And then when it finally finishes, 10 or whatever, it'll like rebang. Okay. So let's now connect that around. Happy, 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 happy. And now we can turn it on and yeah, there goes 10 seconds. Now, here's the problem. Generating 100 grains is okay, except if I want it to be interactive, it will only pick up interactive values every time the script retriggers. So that means that this would have a very low latency, because if you notice how long it took for that bang to happen, like I could be moving a slider over here going, oh, change, and it's not going to change until it hits that bang again. So let's make it generate only 5 of these little grains, okay? I'm just making these numbers up. You could make it even generate just 1 grain. Usually, in the olden days, if you had more triggers like that, it would like really impact the efficiency of this. The computers are fast now, so we could make it do like 1 or 2 grains, but let's just do 5, okay? So now we'll see that it's like bang, 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 bang. Okay, well, how do I make it interactive? These 2 guys, okay? I'm going to make them controllable from the outside, okay? And I'm going to do that by saying that low frequency is going to be equal to variable $1, and high frequency is going to be equal to variable $2. These are special variables in RTCMix. It means that you're going to get a value from the outside that's going to be tagged as var1 or var2. So now, let me save this. By the way, I'm not going to go through the coding, I think, for all of these, okay? Because, yeah, it's going to be too painful, okay? I'm going to put up a slider, okay? Okay, and I'm going to make some parameters of that slider down here. I hit Control I or Command I. I'm going to give it an output minimum of, say, 50. And it's going to be an output max. The range is going to be 1,000, okay? So again, that's going to translate into some nice frequency values, okay, where it will be 50 down here and it'll be 1,050 up there, okay? So how did I get that to come in to be var1 or var2? Well, I simply take that and I prepend the word var1 onto it. And then I send it into RTCMix. Okay, and then I'm going to take the whole shebang, copy it over again. On this one, though, I'm going to prepend var2. So now I've got control of both the low frequency and the high frequency of this thing. So now we can have fun with it. Whoa, it's computer music, guys. Oh, that's so much fun. Okay, all right. So that's what we're going to use. However, I wanted to do something a little bit nicer because, I mean, even though it's like kind of squarish waves and they sound a little bit better, they're still like, just podunky old grains. I'm going to add some reverb to them, and that's going to make them sound a whole lot better. Now, to do that, I'm not going to go through recoding everything. I'm just going to show you what I did, okay? There's 2 different ways to do it, all right? Now, you recognize all of this stuff, okay? Because that's what I just did. And in fact, if you look at the script, it's identical, okay? What you don't recognize is that this RTCMix tilde goes to this RTCMix tilde. Ooh, and I got a bang there to trigger that one. What's going on in here? Well, something very simple. I'm saying that it's going to look for its input audio from the port at the top. And then I'm using this RTC mix instrument called G-Verb, which is I stole that from a Max MSP object called Gigaverb that was popular back in the olden days. And this actually adds a very nice reverb sound to it. So if I turn this on, and let me set a low and a high frequency, and start up, notice that I have this going for 999 seconds. I could make it like 99999. Basically, I just want something that's going to go forever, because once I start the reverb running, all it's going to do is take audio and add reverb to it. And the audio it's going to add reverb to is the nice little grainy thing that's coming from there. So let me start up my reverb, boom, and now. Yeah, notice that I could invert the low and the high freq. Basically, iRAND will always choose between the two numbers, so even if they're out of order, it doesn't have to be like a lower and high value or anything like that. But that sounds so much better. I mean, reverb just makes everything great, you know, so we're going to be happy. However, suppose that I want to translate this into a standalone RTC mix that I'm going to run on a server somewhere where I can't run Max MSP because Max MSP can't run headless, like say PD can or something like that. How can I put that into a single RTC mix script? Well, that's going to be what this patch looks like. Let's see, how am I doing on time? Actually, not too bad. That's good. Okay. Notice there's only one RTC mix object, okay? And this part of the patch will look kind of familiar, except for this Go script 1 and Go script 0. There's OpenScript 0 and OpenScript 1. Each one of these RTC mix objects can have a number of different scripts on them, okay? And the reason I have to have two is I have to have one to initialize it and then one that I'm going to bang over and over again. This is what the initialization script looks like, okay? Some of it you're going to recognize. The reset, setting up the amps, that's stuff that I only have to do once. You know, I don't really need to do it every time I hit the loop, okay? So I just did them all here. And this is also where I have my G-Verb. And it's looking for its input from this audio, okay? However, how does that happen? Well, these guys are what I want to show you. Bus config. Basically, RTC Mix has an internal way of connecting the audio from one instrument to another. And these can be, you know, chains that are really long. That's what Doug Scott was showing off when he did his talk earlier in the semester. But basically, I'm saying take the output of wavetable, and instead of sending it out through out01, which goes out to the world, send it to aux01 out. And your G-Verb, get your input from aux01 in, and then send your output to out01. So this basically takes and does exactly what I did with the patch cord in the previous patch. It takes the output of the wavetable audio, sends it into the input of the G-Verb audio. And once that happens, then I can trigger this script, which is script 1 on the object, and that's the thing by this go script 1 is going to get hit over and over and over again. So to run this, okay, let me get these guys set up. They're happy. I hit go script 0 to initialize it, and then I hit this. Okay. So I just wanted to show you how that was done. That's not going to be critically important for what we're going to actually do today. But I wanted to show you one other way of taking two different parameters and putting them into an RTC mix context for sonification, okay? And that's done. I'm going to do something much simpler in terms of what it does, but more complicated in terms of kind of how it does it, okay? Let me, I don't know if I want to write this all out. No, you know, it's fun to see it once, but maybe after that, okay. I'm going to show you, first of all, this patch, okay? All right, FM-inst. Now, looks very similar to what we did with the granular synthesis thing, only notice that there's no prepend var1 or prepend var2. Instead, we've used an optional third parameter on this RTC mix tilde to specify how many additional inlets we're going to have on the object, okay? So this guy is talking directly into that one, and this guy is talking directly into that one. Well, how do they work? Well, they happen to work like this. One's going to control the carrier frequency of the FM instrument, and the other is going to control the modulation frequency of the FM instrument. Now, I'm not going to go into synthesis in this class. If you want to see how FM works, there's a lot of resources on the web. You can also write me or owner, and we can kind of explain it a little bit. But basically, it's a way of creating sets of sidebands that have harmonic complexity based on the relationship of this carrier frequency to this modulator frequency. And notice that what I've done is I'm using this function called make connection, and it's connecting to an inlet, which is one of those things, and it's connecting inlet number 1 for the carrier frequency, so this is going to be the carrier frequency, and inlet number 2 for the modulator frequency, so this is the modulator frequency. All right, now I don't have a loop here. What these are doing is they're going to reach into this FM instrument as it's synthesizing and modify those parameters. Those parameters we called P fields for very, very old historical reasons. It has to do with positional parameters, which were a big deal back in like 1979, okay? But if you go to the RT-CMIX documentation page, you'll see things that are called P field enabled. In fact, I can show you that right here. Let me bring this up, okay? rtcmix.org, oops. Oh, come on, why didn't you, there we go. So if we go to the reference and we go to the instruments and we go down to our synthesis, we go to FM instrument, okay? Okay, it says capitalized parameters are P field enabled, okay? This will actually take you to a link that will kind of walk you through some of this stuff, okay? But the carrier frequency and the modulator frequency, in addition to some other stuff, are what we call P field enabled. So that means that I can use this variable and this variable here as the carrier frequency and the modulator frequency. And if I move them, change their values, they will dynamically affect this FM instrument, which again, I've set it up to just run for a very long time. So that if I start this up, okay, then I can change. Okay, that wonderful FM sound that we all know from the 1980s and Yamaha DX7 synthesizers, okay? So that's another way of dealing with two different parameters. And of course, what I did with that was I added, not reverb this time, but I added another RT-CMIX instrument called pan echo, okay? And it's taking its input from this AUG01 thing. And pan echo, well, you'll hear exactly what it does. It's very, very straightforward, okay? It just goes like this. Which is really fun to play with for hours and hours. Okay, so again, I just wanted to show you that, another way of dealing with two different parameters, but we're going to use the granular patch for the network stuff. All right, okay, network stuff. Now we get to the fun part, okay? Turns out the patches for doing this are ridiculously easy, okay? There are two max MSP objects that are going to be important for you to do, okay? One is called UDP send, okay? And you have to give it two arguments, a host name and a port, okay? And these can be overridden, but I'm just going to go ahead and put some in. Now, when I was talking earlier about those like network address numbers, the 192.168. whatever, those can also be represented by strings, like music.columbia.edu or brad.music.columbia.edu or any number of things, okay? But one of the strings that's really easy is called localhost. And let's just make up a port. Let's say we're going to go to port 7878, okay? Let me make this bigger. Okay. This will take values coming in and send it to the local host, which is this computer that I'm on right now, port 7878. And you might have guessed UDP will send a UDP packet, or one of those universal datagram packets. So let's just put up an integer box and we're going to send it, okay? All right. Now, that's one half of the equation, okay? The other half, and I'll just do this in a completely separate Max MSP window, is UDP receive, okay? Make this be bigger too. All right. And UDP receive, you can give it a host name and everything like that, but I'm just going to set it up here. I'm just going to say, port number 7878. So UDP receive is going to just sit here on this computer, on this host, and it's going to receive stuff, okay? And now, we'll see it, okay? So now, oh, I have to say port, right? Yeah. So now if I watch what happens when I hit this, bang, it says UDP receiver binding to port 7878, all right? This is going to send numbers to port 7878 on our local host so that, watch, this is magic. Whoa. See, numbers are going to both places, all right? That's the essence of doing this networking control stuff, okay? Now, here's where it gets fun, okay? Let's just do a couple of things here. Let me set this up, and I'm going to show you a few more things here. Let's say host 127.0.0.1. Send that in here, okay? And let's send port, oops, let's send port 8787 into this one here, okay? And just for fun, let's also keep port 7878. Okay, again, these are numbers above 1023, which means I can just use them willy-nilly, okay? And let's go over here, and let's now set also here, we can say port 7878. Oh, 8787. Okay. So now we can go here, and if I change this to this host, bang, I send it on port 8787, I set this to receive on 8787, we get same thing. Why is that? Because this internet address, 127.0.0.1, is reserved to be the local host, okay? However, we can use another host number here, okay? And let me bring you, I want to show you how to do this. I'm going to show you how to do this on Windows in a second too, okay? This machine, in addition to having that address, has another address, the address that your local area network sees. And you get that by going to your preferences, all right? And you can go to network, and then you can go to advanced, because this is advanced. And then if you hit the TCP/IP thing here, it will tell you, look, your network address, the IPv4 address, okay, is 192.168.1.4. So I can go here and I can say 192 host. There's also a name for it, but it's kind of goofy. I'm not going to use it. I think it's called woofing.local or something like this. So now, I'm going to close my system preferences. Let's listen on port 7878. Let's set this to broadcast on port 7878. And let's set it to this host. Boom. Okay. So this is the address that kind of the local area network is seeing. And we're going to use that in a second, okay? But I want to bring up the granular stuff in a second, okay? So, in fact, let me do that now, okay? So this is basically the framework that we're going to use to kind of like send our different internet stuff back and forth. Let's not save this. Let's not save this, okay? And let's bring up our UDP gran.max patch. Okay. All right, now a little bit bigger. This is basically, I took the granular thing that we did, okay, which you will see here, okay, and it's got the Go script 0 because it's got the reverb on it and everything like that, and it's going to be receiving on port 8888, okay. Now we're going to be sending data that's slightly more structured this time instead of just a single integer, okay. It's going to be structured to have the message low freq and high freq attached to each data packet that we send, and we're going to then route that, and we're going to prepend var1 or var2. That's how we're going to like do the equivalent of the sliders. Okay. Well, let's see, how do we set that data up? Let's go here to UDP send. Okay. Make it a little bit bigger. Okay. And bring this down here. Okay. So there's our sliders. Only now instead of prepending var1, we're prepending low freq. We're prepending high freq. Because when we send that, that basically will then say low freq and then a number, or high freq and then a number. And that's what we can split out with this route thing. Now, this opens up a world of possibility. You probably heard me refer to a thing called Open Sound Control, or OSC. OSC was developed at the Center for New Music and Audio Technologies at the University of California, Berkeley. It's basically a very sophisticated way of structuring data so that you can create very strong hierarchies of data that you can route in different ways. And it has a bunch of concomitant objects that allow you to unpack the data in different ways. Yeah, I mean, obviously for things that are much more complicated than this. OSC was thought to be the replacement for MIDI at one point, but it never quite caught on in that way. However, it's become very useful in any number of applications now. I think, Anthony, was it you that was telling me that you were using it for controlling lighting?
Yeah,
Something like that?
lighting, audio, video control,
Right.
talking to each other.
Right. So basically it had this OSC UDP kind of sending stuff all connected, and everything could connect together, and you could like get the lights to happen and do cool things. Okay. All right. So here we go. Now, I have this host. This is what's tricky. Most computers that you guys now use, and in fact, the computer I'm using right now, let me bring up my system preferences again. And I want to show you something here that's a little tricky. Okay. Network. Okay. All right, and we're going to go to advanced. Okay, and we go to TCP IP. All right, this is my IP address, 192.168.1.4, but notice that I have a different one here, 192.168.1.7. That's because this is using a thing called DNS. Is it DNS? No, that's domain name service. It's basically, it's a dynamic, DHCP. Yeah, DHCP. Okay, it's a dynamically assigned address, so that every time you reboot your router or turn your computer off and turn it back in, it actually requests an IP address for its local network from the router. And they can be different. There's ways of configuring your router to always give your computer the same address, but I don't want to go there right now, okay? So basically, for this to work, I'm going to have to take this, I'm going to have to modify this so it can be 4, okay? Because it's going to send to, I could have said a local host here or something, but there's a reason I'm doing this. I'm going to tell you, I'm going to show you that in a second, okay? So let's set this all up, okay? Going to communicate to this host on port 8888. Okay, let's go over here. We're going to initialize our reverb, start our sound. Okay, and now don't hear a thing, do I? Port 8888.
Looks like something's going on the console.
Yeah, hold on a minute. Where did it go? Oh yeah, there's all kinds of redness there. Okay. Okay, but this should be like, hold on a second. Okay. Oh, I forgot to set my receiver to listen on port 888. I have to click this one too. Yeah. Now, oh yeah, now we're cooking with gas. Okay. Yeah. So the receiver was basically listening on some other port and it wasn't getting the data. These ports are important, you know, keeping everything correct. Okay. So now let's hit our Go script, hit this. And now we're controlling it through the internet. Ooh. Okay. All right. I want to do one more thing. I'm going to close this guy off. Okay. And yeah, I think this will be the last thing I'm going to do today. Okay. And I'll explain why it's the last thing I'm going to do today too. All right. Now, what I'm going to do here is kind of tricky because I want to show you just how much fun you can have. All right, let me get this going in here. Let me go up to my Macs, open recent patcher. I think it's there somewhere. Yeah, camera.max patch. Okay. All righty. Okay, now let me get my device list. Okay, and let me set it up to my USB camera. Now, yeah, there we go. Okay, so can you see me now? Okay, can you see the top of my head? No, I'm kidding. Okay, all right, what I want to do, okay, is go over here. I'm trying to rearrange all these guys, okay? So you can see the patches here, okay? I'm going to go over here to my Windows computer, okay? There it is. This is why, hey Ross, this is why I was asking you if you could log in with more than one computer earlier, and I probably should have done that, okay? Because it would be a little bit easier to see what's going on now, okay? But basically, here's my Windows computer, okay? And I'm going to start up my UDP send patch that I have running on Max MSP here. Let me get this camera out. Right. Okay, there it goes. All right, now, again, I have that UDP, that host set at, yeah, well, you can't see it, but it says 192.168.1.7. Remember, I have to change that to 192.168.1.4. And I also have it set to port 7878. And now I'm broadcasting on port 8888. So I'm going to set my camera down and switch those, okay? So here we go. Oh, wait a minute. Okay, 4. I need to modify this patch because I forgot. This is just the basic UDP send patch. Okay. All right, and I want to do the following. Okay, sorry guys, this is going to take me a second, and you're not seeing what I'm doing, but pretend like you are. Okay. Okay, I'm going to say in prepend low freak. Oh, lordy. I'm glad you guys aren't seeing this because it's just painful watching me try and like patch chords on a mouse that I'm not that familiar with. I mean, I'm not very good at this anyhow. Okay, so let's do that. Let's copy these guys. And make that be prepend high freak. Okay. Okay. I believe this is now working. Hold on. Yeah, patch that up. Okay. Now port 8888. Let me go over here to receive on port 8888. Okay. And let me make sure. Okay, all right. Now, what I did was I set this computer to be host 192.168.1.4, send that in, then port 8888, send that in, and then this is my low freak value coming in, this is my high freak value coming in. So now I go back over to my Macintosh, start up the script, make sure it's set receiving on port 888, excuse me, I did that wrong. Okay, start up the script, hit this port, here are our stuff, and now I'll go over here to my Windows machine, and I'm switching, controlling it from there. Okay. So, life is good. We are communicating from one machine to another. Isn't that remarkable? After that incredible sort of presentation by Ross, it's like, oh my goodness, I can send numbers from one machine to another, which is kind of silly, okay? Let me turn off this camera here. Close. I don't really need to close it, but I'm going to turn that off. Okay. All right. Now, the final stage that I was going to do was to show you that, in fact, you could control this over the great wide internet. And Owner was going to send me patches. All right. However, there's a problem. We're going to try and solve it. And hopefully, like next class, we can show you what to do. Okay. There's a number of things that could be going wrong. Okay. Remember, I told you that when you look in here, you can get your IP address for this machine. Now, remember when I said that there's this thing called network address translation to deal with the fact that the internet is like too small, but we have all these other machines underneath it? Well, this address is not seen outside of my router that's sitting upstairs, okay? When that router sends stuff out into the great wide world, like to all of you guys for this Zoom session, it's doing this weird net address translation. And in fact, I can go to a website called whatismyip.com, and it will tell me this computer, when it goes out to the outside world, it has this IP address, 66.165.14.212. All right. Now, if I tried just setting this up here, oh, then I'll just type it in here to, you know, oh, where's my other window here? I don't have it anymore. But if I set that up as my kind of, let me just bring this up. If I did my host, you know, 66.15. Whatever, it wouldn't know what that is because it only sees network addresses on this side of the LAN. In order to get this to work from outside, you have to use a thing called port forwarding. And that means that you have to go to your router. And my router upstairs has like all my machines that I have connected to it in like a routing table. Okay, and you can actually edit this thing. I'm not going to go through this now because it's kind of painful and annoying. And I can actually say, all right, for this particular machine, this machine that's on 192.168.1.4, okay, I want you to take port 888 and forward it so that then if Owner connected to that IP address with port 888, the router should take that and then send it into my local address Macintosh. However, we just simply couldn't get it to work. There's any number of things that could have gone wrong. I've got some ideas for how to try it. It could be that I actually have two separate routers because I may have a separate router that was provided by my telecom company that I'm not seeing, and that might have some kind of like, you know, it does not do the port forwarding. There's also issues with what we call firewalls, which are now ways of protecting your computer from malicious incursions and data stuff. In fact, what's really fun is at this whatismyip.com, there's all kinds of fun things that you can do here, okay? This tells you kind of information about port forwarding that we've got to kind of look at. but you can also do what's called port scanning. Where is that? Oh no, that's using a different tool. But you can actually scan a particular IP address for every single port that might be open. And if you're a malicious hacker, you might be able to use that to do maliciously hacky things. Back in the olden days, everybody was nice and they didn't do this stuff. Yeah, right. Anyhow, we got to look at it a little bit more and try and figure out what's going wrong, because it would be fun to be able to do this. To be honest, though, if you want to set up a serious project that has a lot of like broadcasting to the world with some possible kind of feedback control or something like that, or that's taking data from somewhere else, I'm going to stop my screen sharing now, okay, because I don't need it anymore. Or is taking data and sonifying it and you're putting it on like some kind of a network radio station or something like that, you really want to do what Lara did, and you want to get your own virtual machine with a fixed IP address, okay? I looked into what would be involved at Columbia. Columbia actually has a contract with Amazon Web Services, which should allow you to create a virtual machine, but sadly, it's not free. And you might be able to, if you're going to get serious about this, let's talk and we can, possibly come up with a way of kind of dealing with stuff. Next week, I'll be talking about ways that you can use my existing machine to do some experiments with, and we can kind of go from there. But realistically, yeah, because you just noticed earlier in this talk that I gave that the network address of this machine is going to change. That means that if I rebooted my router, or if I restarted this machine and had a different address, I'd have to redo the port forwarding on my router in order for people to come and talk to this machine. So that's kind of ridiculous. But I wanted you to see kind of what was involved in getting machines on the internet to talk to each other. And hopefully you've got this, okay? All right, we're coming close to the end of the class now, and that's about as much as I wanted to cover. Is there any questions or comments or anything like that about this? I mean, is this just like too bizarre? Again, this is kind of what the point of the class is going to be, was to ultimately lead to this. Then when we hear from Miller and company the following week and look at some of the stuff that Ross has got for us to see, we can start looking at audio back and forth and doing fun things like that. Yeah. How'd this go? I hope it was okay. Oh, I got a message. Oh, message, good. Okay. Oh, there's a bunch of messages that I missed here. Oh, Herzog, yeah. Werner Herzog, he's great. I had his son in one of our classes at the CMC a few years ago. Seriously, he's a really nice guy. Okay, here's something from David Reeder, okay? There you go, yeah. Sorry, I'm just looking at the chats now. Right. Okay. Cool. Okay, gang. That's it for now. John, I hope this was informative in terms of, doing some of the things you're interested in doing. We'll kind of keep pushing his stuff and see where it leads us. And yeah, in the meantime, let's see what happens in the world. Hopefully life will be good. We'll see. Alrighty, gang. See y'all next week. Bye.
Thank you, Brad.
Sure.
Thank you.
Thank you.
Thanks, everyone. Reach out if you got any questions. Happy to help.
Yeah.
See ya.
Definitely. Ross, that was fabulous. I really appreciate it. Okay.
Thanks again for having me. Bye-bye.
Thanks, Ross.
Bye.
Thank you. Bye.
Thank you. Bye-bye.
Okay, I'm gonna send Annie away.
We're still recording.
I'll get it off. Thanks.